Hi everyone, I'm Jackie, and today in this video I'll be covering the SAT Must-Know Math Concepts Advanced Quadratics. Advanced Quadratics appear on every single SAT exam in some capacity. These problems in particular have all appeared on past official exams, and SAT is known to repeat the problems slash concepts, not the exact problem, but the exact concept. So you want to make sure that you know how to solve all these problems. So per usual, let's jump in. Okay, so let's see. For a certain type of rope, the equation y equals 900, ax squared is a constant, gives the estimated breaking strength y in pounds of a rope with a circumference of x inches. Based on this equation, if a rope of this type has a circumference of 2.75 inches, it has an estimated breaking strength of 9,528.75 pounds. What is the estimated breaking strength in pounds of a rope that of this type that has a circumference of 7.5 inches. Okay, so first I'm just going to substitute in the break-in strength, 9,528.75 is equal to 900 and then my x would be 2.75 because that stands for the circumference, and then squared. In doing this, I'll be able to solve for what a is. So let's see, this would be 9,528.75 is equal to 900a, 7.5625 multiply by 900. Okay, so this would be 6,806.25a. And then I'm going to divide each side by that. So 9,528.75 divided by 6,806.25. And that actually gives me exactly 1.4a. Okay, so now I use this information and I go back and I will plug that in for the a value. So this would be 1.4 now multiplied by x squared. I'm trying to find the breaking strength. Then I just do y equals 900, 1.4 multiplied by 7.5, 0 squared inches, which gives me precisely, well, let's see, dirt. Oh my goodness, 70,875. And that would be our amazing answer. Okay, moving on. This one, the function r of t is defined by the given equation. The function s is defined by s of t is equal to r of t plus 1, which expression represents the maximum value of s of t. So first thing to recognize, this is a quadratic equation. Put differently, I can re-express this as r of t is equal to negative t squared plus 55t plus 0, just to show the ax squared plus bx plus c. And if I ever want to find the maximum, aka the vertex, the x-coordinate of the vertex, I can do h is equal to negative b divided by 2a. So in this case, it would be negative 55 divided by 2 times negative 2. So this would actually result in having a maximum x-coordinate at 55 over. So important, this is my x value, and I'm asked for the maximum value of s of t. So first I want to find out what the y value is at when x is at 55 fourths. So what I'll do is I'll put in 55 fourths, substitute that in for t. Do dee 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 dee. And then minus 255 fourths squared. And let's see what that gives us. So this would be 3025 over 4. 3025 divided by 4. This 2 would be this would be again, so like 2 multiplied by 3025, distribute to the top and the bottom, so over 16. And then well, just to show, this would then become, so 3025 over 4 minus 2 times 3025, so 6050 over 16. Then we can also even reduce that further. So be 3025 over 4 minus 3025 over 8, find common denominator. Okay, so this will eventually simplify to 3015 over 8. Okay, which just means that my maximum value, what it's at 55 over 3015 over 8. That's for the R of t function. Okay, and since I'm asked for R of t plus 1, so basically this just means that it's going to be shifted up 1 unit. The y value is going to shift up 1 unit. So what I'm going to do now is just take this and add in the 1. So I do 3015 plus 1, which is the same as 8 over 8, which will be 3023 over 8. Okay. Okay. But I'm actually overcomplicating because I can see that basically it's going to be this plus 1. And looking at how I was getting the maximum value, it eventually simplified to, well, we see 30 over 20, 3015 over 8, which I got from doing the subtraction here. So essentially what was happening, if I look at this, it's 55 over 4 squared multiplied by 2, and then I added 1 to it. So just looking at before I took all these steps here, it would be this and then plus the 1 because it's the y coordinate that's being translated up 1 unit. So could have saved myself some time by just looking at that, but anyways, this is just one way in which they could test the minimum or maximum of the vertex. Okay, next up we have a quadratic model gives the predicted instantaneous rate of change in bacteria per hour of a bacteria population as a function of the population size. According to the model, the predicted instantaneous rate of change is 0 bacteria per hour for a population size of 0. And the maximum predicted instantaneous rate of change is 0.200 bacteria per hour for a population size of 7,000. Based on this model, what is the predicted instantaneous rate of change in bacteria per hour of the bacteria population for a population size of 700? Okay, so if you've seen my other videos, you've probably noticed doing a very similar question. Very similar, however, different numbers, but always here. So note here they give me a coordinate pair. This would be 0, 0. And they also say the maximum predicted instantaneous rate of change. So remember maximum, whenever you see maximum or minimum, that means the vertex HK of the parabola. So in this case, it says rate of change is 0.200, population size 7,000. So my X is 7,000 and my Y value rate of change is this. Okay, so whenever I'm given vertex form, It's y equals a x minus h squared plus k. This is vertex form. And I can always derive the equation of the quadratic if I have the vertex and I also have another pair of coordinates. And that's exactly what I'm going to do to get the quadratic model. So for x and y, I'm going to put in 0. My h value we established is 7,000. And my k value is at 0.2. Not sure why they put those extra zeros in. And let's see, so 7,000 squared is really quite large, which is a great problem to do on your calculator. Okay, so I would subtract, well, just to write the whole process out, this would be 49 million A and then plus 0.2. Subtract the 49 million from each side. Do. And then I'm going to divide 0.2 by 49 million. Okay, so this is going to give me 4.0 approximately. A would be equal to negative 4.08 multiplied by 10 to the negative ninth power. So then going back to my original model, my A value is negative 4.08 times 10 to the negative ninth. And then we had x minus 7,000 squared and then plus 0.2. So final step, I have the model, so I need to find what the bacteria population is for a size of 700. So now I'm going to plug this in for x. Do. And then plus 0.2. And let's see what that gives me. Okay, and then we can see I just typed it into Desmos and negative 4.8 times 10 to the negative 9, 700 minus 700,000 squared plus 0.2 gives me the correct answer, 0.38. And that is what I would enter as my answer. Mm. So amazing. So let's continue our journey. Okay, so this one may look familiar to students. It's definitely from, well, the concept or problem. It's from a Blue Book exam. I feel like it's Blue Book exam 3 or 4. It's not the same problem. It's almost pretty identical, but if you don't know it, it's a great problem to do. And also, it's a great problem to demonstrate that it is a really good idea once you feel confident with your skills in algebra, advanced advanced math, problem solving, and data analytics and trig to go through all the Blue Book exams before you take the SAT. But anyways, let's jump in. So here I have the quadratic. It says in the given quadratic function, a and c are constants, the graph of y equals f of x in the xy plane is a parabola that opens upward and has a vertex at the point hk, where h and k are constants. Okay. And then it says blah, blah, blah. If k is less than 0 and f of 8 is equal to 2, which of the following must be true? Okay, so where would this actually occur on a parabola? Like where the x values are equivalent to each other. And so since I know like the points of x, so let's say 1, 2, 3, 4, 5, 6, 7, 8, -8, this is +2. It doesn't necessarily have to be the x intercepts, like maybe it's here, maybe it's here. But I do know that it seems like A is positive, so it will open up. Just to show, the vertex is always equidistance between the two x values that are equal to each other. So basically, the distance between -8 plus 2, when I divide that by 2, finding the midpoint, that will give me the vertex, aka the x value of the vertex, which is -3. Okay, so the vertex of the parabola will be around -3. And this is because this is the axis of symmetry. Parabolas are symmetrical. And now I know the line of symmetry and the x value of the vertex. Okay, so now that I know that, what I'm going to do is use that information and plug it into vertex form. So here be x plus 3 squared plus k. And then I'm going to expand to put it into standard form. So this would become x squared plus 6x plus 9 plus k. And this would be ax squared plus 6ax plus 9a plus k. Remember, it says it was equal to this equation. Okay, so I can see, right, 6a would correlate to the b value. So I know 6a is equal to 4. Therefore, a is equal to 2/3. So a is greater than or equal to 1, not true. Discard any answer that contains 1. Likewise, I know the c value here would correlate to 9a plus k is equal to c. And we can go ahead and substitute in the a from here. So 9 times 2/3 plus k is equal to c. So this will be 6 plus k is equal to c. So k is equal to c minus 6. And also in the problem, I'm told k is less than 0. I know k is equal to c minus 6, so I can say c minus 6 is less than 0. So c is less than 6. So must be true. It's not less than 0. It's less than 6. Also not true. So therefore, I can safely deduce that this is a neither 1 or 2. Oh my goodness, how amazing. Okay.
It says the function f is defined by ax squared plus bx plus c, where a, b, and c are constants. The graph y equals f of x, and the xy passes through points 7, 0, and -3, 0. If a is an integer greater than 1, which of the following could be the value of a plus b? Okay, so first of all, I'm given the x-intercepts here of the equation. So if I'm given the x-intercepts, I can use them to create a quadratic equation. So I'll definitely be using roots form, so these are the two other ones, but roots form, it's y equals a, like x minus root 1, we'll say, and x minus root 2. Okay, so since here it passes through the points +7, that means that it would be +7 inside. Sorry, -7 inside. And here it would be +3. Why is that? Because x plus 3 equals 0. So that gives me one of the x-intercepts, which we see here. And likewise, x minus 7 equals 0. That will give me x equals 7. So looks just like that. Next step, expand the brackets. So let's expand. This would give me x squared. I'll just show the steps. Plus 3x minus 7x, and then minus 21. Simplify further. So I have x squared minus 4x minus 21. And then I can distribute the a everywhere. So I have ax squared minus 4ax minus 21a. Okay, and remember this is defined by this equation. So just to show, ax squared plus bx plus c. So from here, I for sure know that -4a is equal to b. And I can also see that -21a would be equal to the c value. And also with that too, I can see a is simply equal to a. Okay, so then asking for the value of a plus b, Well, let's substitute the values in. So I have a plus b. I'll put my a value here. I'll put -4 value in for b. So that would give me a minus 4a. And that's equal to -3a, right? So I can say the value of a plus b is equal to -3a. So first of all, I have -3 in front, um, which indicates that this must be a multiple of 3. So the only multiples of 3 are a and b, so I can completely discard c and d, have a 50-50 chance of getting this one right. And then from here, go back to the problem. It does highlight, it says a is an integer greater than 1. So that basically means like a, remember it's an integer. So if it's the first integer that's greater than or equal to 1, it's 2. So I know a is going to be greater than or equal to 2. And from here then, like a possible value could be -3 times 2, because that would be -6. It can't be this one because that would be -3 times 1, and it says a is greater than 1. So therefore, it must be -6. Okay, but you see how I'm able to derive the quadratic equation by my knowledge of Root's form.
This one, a quadratic function models the height in feet of an object above the ground in terms of time and seconds after the object was launched. According to the model, the object was launched from a height of 0 feet and reached its maximum height of 1,600 feet 10 seconds after it was launched. Based on the model, what was the height in feet of the object 15 seconds after it was launched? Okay, so remember, if you ever see maximum or minimum, it's telling you the vertex of the parabola. And I can use vertex form to solve this quite nicely. So example, I know the vertex here, it happens at 10 seconds, 1,600 feet. So vertex 10, 1,600, that would be my center coordinates. So it'd be like, okay, so this is x minus 10 squared plus 1,600. And then since I'm given another pair of coordinates, important, it tells me it was launched from a height of 0 feet. That means that another pair of coordinates here would be 0, 0 that occur in the quadratic function. So I can use those, substitute them in for x and y here. In doing so, I will get the value of a, and I will have my complete quadratic module. So let's do that. 0 equals a, 0 minus 10 squared, plus 1,600. So here I would get that this is 100 a plus 1,600. Negative 100a equals 1,600. So I get that a is equal to -16. Therefore, a final model would be y equals -16, x minus 10 squared plus 1,600. Amazing. And then the final step in this process, based on the model that I have here, what was the height in the feet of the object 15 seconds after it was launched? So now I just have to substitute that in for x. Do dee 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 dee. Which this will be y equals -16, 15 minus 10, that would be 5 squared, so times 25 plus 1,600. -16 times 25, it's -400 plus 1,600. And therefore, I get my answer, which is that at 15 seconds, the height of this object will be 1,200. Wasn't that amazing? Continuing our journey. Oh my goodness, a circle equation. Okay, so a circle in the xy plane has a diameter with endpoints A11 and AD. So note they have the same x coordinate, where a and d are constants. An equation of the circle is x minus a squared plus y minus 17 squared equals radius squared, where r is a positive constant. What is the value of d? So first from here, I know that the center, it's positive a, positive 17. So I can see all these coordinates, they have the same x value. I don't know what the x value is. It can be any value, doesn't matter, but I'm just going to say here that let's say it's at 0. And therefore the y value here, like let's say it's at 17, another y value would be at 11. Then I can find the distance between the endpoint to the center, which in this case it's 6. So radius is 6. And then if I want to go up, I want to find the other endpoint. So the other endpoint will be on the other side of the radius, which would be here. And I would just do to find this 17 plus 6, which is 23. And that would be, the D value here. So important things to remember about circles, and just to show like this would maybe look something like this to create a circle. Um, so the center coordinate, if you have two endpoints, if you do the midpoint of the two endpoints, it will lead you to the center of the circle. And just to prove that, like if I do 23 plus 11 divided by 2, that will be 34 divided by 2, which is in fact 17. Amazing, right? So know that concept for the exam. Okay, so this one too, a very similar one, if not identical, appears in Blue Book Exam 5 or 6. Students reported back they had this exact same question or very similar, just different numbers on the exam. So let's see. A circle has a center G. Interesting. Okay. Sorry, I just want to make this a good visual for you. Okay. All right, so we have center G. And points M and N line the circle. Line segments MH and NH are tangent to the circle. Okay, so I have M. We can put N here to create tangency. And okay, so then I have some external point. Let's say, well, it's H, and then they create these tangent lines. Okay, so if they're tangent, well, that could be maybe drawn better. One moment. We'll put it here, H. So tangent is creating these right angles. And then likewise, I also have from the center to the endpoint, this is giving me the radius, and from G to N, also giving me the radius. Okay, and then it says if the radius of the circle is 168, so this is 168, this is 168, and the perimeter of quadrilateral GMHN is 3,856 millimeters. What is the distance? Okay, so then I have to find the distance between G and H. Well, first things first. So something important to take into consideration is that um, take note of this, like tangent lines that come from the same external point. They, in this case, our external point being H, right? They are always congruent. So are always, no exception, congruent. So why is that helpful? Because then I know like I can label this X and X. Now I can do 2 times 168, for the radius, plus 2x for the two sides here, and that's equal to the total perimeter, which is 3,856. And then I can, solve 2 times 168, it's 336. So I get that 2x is equal to 3520, and then divide each side by 2. So I get that x is equal to 1760. So each of these would be 1760, 1760. And then final step, I need to find the distance between G to H, which is, you can see I could do Pythagorean theorem. I could do 168 squared plus 1760 squared is equal to like GH squared. And I could solve that, however, saving time. Hypotenuse, which is what we're solving for, it's the longest leg. So it must be larger than 168 and 1,760. So looking at the answer choices, it must be 1,768. Isn't that amazing? All right, continuing our journey into an SAT classic, absolute value. Okay, so here I'm asked for important, the sum of the solutions. So I have x minus 8, absolute value brackets, is equal to negative x minus 8 plus 20. So since these two are the same um, expression inside absolute value, I can add this to the other side. So I can be like, okay, so x minus 8 absolute value plus x minus 8, you see I'm just moving this over, is equal to 20. So now since they have the same expression inside, pretend there's like an invisible 1 here. So when I combine them, it becomes 2x minus 8 is equal to 20. Divide each side by 2, so I get x minus 8 is equal to 10 in absolute value. And then since I'm solving for absolute value, it's equal to a positive output, which indicates there will be two solutions. To solve, I need to set it equal to its positive value and also to its negative value. So x is, in this case, equal to 18. And then I have one solution that this would be x is equal to negative 2. So my two solutions are 18 and negative 2. The sum of them would be 18 plus negative 2, which is 16. And that would be the answer. Wasn't that amazing? Continuing our journey. Oh my goodness, a trig question. Okay, so we have 2 cosine 90 degrees minus a. I'll continue times cosine b plus sine of a plus y degrees multiplied by sine 90 degrees minus b, where sine of a degrees is equal to 0.50, cosine of b degrees is equal to 0.99. 0 degrees is less, okay, so b is in between 0 and 90. What is the value of the given expression when y equals 0? Okay, so you definitely want to know and utilize your trigonomic identities here. So let's apply them. So remember, like in general, cosine of 90 minus x is equal to sine of x, right? So looking here, I can say cosine 90 minus a, that's the same as sine of a. Likewise, here, sine 90 minus b, that's going to be equivalent to the cosine of b. Okay, so that can help us simplify. Because knowing that, I can be like, okay, so here, this is just another way to say sine of A. So I would have 2 sine of A times cosine B plus sine of A plus Y. So just to show this one too, it says when Y equals 0, put in 0 here. So this would be sine of A plus 0, which is the same as sine of A. So this would be sine of A. And then times sine 90 minus b, remember I'm making this to cosine. So it's multiplied together. So times cosine of b. Okay, and so I have this plus sign in front. I have two values that are the same, cosine b. I could factor it out. This would be the same as cosine of b. When I combine them together, it would be like cosine b multiplied by 2 sine a plus sine a, that's an a, which becomes, so basically cosine b times 3 sine a. So remember there's like this invisible one in front. Okay, and then my final mission, if it says that cosine of b is 0.99, so I'm going to go ahead, substitute it in, 0.99, and then multiplied by 3 sine of a, and sine of a is just 0.5. So 3 times 0.5. And that should give me my answer, which let's see what that is. Times, oh my goodness, it's equal to 1.485. And that would be our answer. But you see how basically this is just knowing your trig identities. And just the very classic ones that cosine of 90 minus x is equal to sine of x, and sine of 90 minus x is equal to cosine of x. Trig identities, amazing. Okay, so make sure you know all these concepts for whenever you take your next SAT exam. And if you like this video, like, rate, view, subscribe to the channel, and I will keep posting more content per usual, and I will try not to take as long as a hiatus as I did. It was only a couple weeks. Okay. So bye guys. I'll see you in the next video.
In this problem here, it gives me quadratic like equation, and it tells me that the exoplane is a parabola that opens upward. So A is positive, has a vertex at point HK, where k is less than 0, and f of -9 is equal to f of 3, which of the following must be true? Okay, so first, why would f of -9 and f of 3 be equal to each other? Where would that occur? Oh yes, where y is equal to 0 is where they would equal each other. And that's basically aka the x-intercepts of the parabola. So just to look at this on a graphing perspective, if this is 0.3, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is -9. I have a parabola. I know it opens upward. So I can actually get what the midpoint or the center x coordinate of the vertex is, because I know it will be the midpoint. So this coordinate here, h, is equal to the midpoint, which I can do x coordinate 1, x coordinate 2 divided by 2, which would be -9 plus 3 divided by 2, which is -6 divided by 2, which is -3. Okay, so I know then that my vertex is around here. Remember, parabolas, they are always symmetrical. Okay, so that's why I know that the x-coordinate of the vertex, it's equidistance from this x-intercept and to this x-intercept. Okay, amazing. So why is that amazing? Well, now I'm going to go to vertex form. And remember, vertex form, super important formula. Know this for digital SAT. Okay, but let's plug in with what I know. I know that this is -3. Inside the square will be the opposite sign. And now I can expand my brackets. So when I expand, this becomes x squared plus 6x plus 9 plus k, and then I distribute my a. So this is ax squared plus 6ax plus 9a plus k. And remember, this is all equal to this equation here, which is ax squared plus 4x plus c. Okay, so here I can see ax squared is equivalent to ax squared. Likewise, I know that, look at the coefficients to guide you. The 6a must be equal to 4. So if 6a is equal to 4, that means a is equal to 2/3. So a is greater than 0, or greater than or equal, sorry, a is greater than or equal to 1. No, not true, it's 2/3. So I know 2 is not true, so can't be B and can't be C. So I already have a 50-50 chance of getting this one correct. And then likewise from here, let me make this red. So I know that my C value is this. So 9a plus k is equal to C. I have my a value, so I can plug that in here. So 9 times 2/3 plus k equals c. So 6 plus k equals c. k is equal to c minus 6, I'm also told that k is less than 0, so c minus 6 must be less than 0, and c is less than 6. So c is less than 0, no. Therefore, it must be correct choice D. So moving on to our next problem. So it says, in the xy plane, a parabola has vertex 9, -14, so h and k, and intersects the x-axis at 2 points. Interesting. And the equation is written like this. Which of the following could be the value of a plus b plus c? Okay, so first, whenever I'm giving the vertex, I'm going to do y equals a x minus h squared plus k. Okay. So I know my vertex form formula. I'm given the vertex coordinates, so I can easily plug it in. And that will be a x minus 9 squared. Remember, if it's positive here, the h value, it will have the opposite side inside the square. And the k value is minus 14. And then I will do x minus 9, x minus 9, minus 14, expand the brackets. That becomes x squared minus 18, x plus 81. And then I will distribute the a to everything. Plus 81a minus 14. Okay, so I have my a value, it's just a, b value here, negative 18a. And then I have my c value, which is 81a minus 14. I'm asked for the value, or could be the value of. So now I can sum these. This is 64a minus 14. Okay. So then I look at the answer choices and I'm like, oh no, this isn't an answer choice. Well, I'm looking for what could be the value. Important. I'm told that this crosses the x-axis at 2 points. Imagine here, if I have the parabola and my vertex is around here, let's say this is the 9, -14. In order for it to intersect the x-axis at 2 points, it must open upward. Okay. So I know that if it opens upward, that means that a must be positive. Lucky for us, I'm given an equation here, 64a minus 14, that I can solve for a. So let's see. For example, a is -23. So if I have -23 set it equal to the equation is equal to 64a minus 14. And I add the 14 to each side. That'll give me -9, 64a. But anyways, here, just to save time, I would stop because I can see that this results in a negative value of a, and I'm looking for a positive value of a. Positive. So can't be this. B, same thing. Also, I can see that I am just moving the -14, so I'm adding 14. So this would also be negative. I'll just write it out for learning purposes. So this would be -5, 64a. That'll be negative. C will result in a 0 value, which also no. So therefore, D must be our winner, but let's make sure and see why. -12 is equal to 64a minus 14. So I get 2 equals 64a, and 2 64ths equals a. That is my only positive value, and therefore that must be our answer. Okay, so you see this one, make sure you know vertex form. if you get to an equation like how we saw, be like, okay, and what? Go back to the question and see if there's any keys within the question that can help you solve. Okay.
Thank you so much for watching. I hope you enjoyed this video and these questions, and please like, rate, and subscribe if you like this video and my channel and you want to keep seeing more videos. Thank you so much for watching, and I hope to see you in the next video. Bye.